Assalamu alaikum. Welcome to lecture number 18 of the course on statistics and probability. You will recall that in the last lecture I discussed with you the concept of permutations and combinations, and after that we discussed a number of important and fundamental concepts such as the random experiment, the sample space of a random experiment, the concept of events, and different types of events such as the mutually exclusive, the equally likely, and the exhaustive events. In today's lecture, I will discuss with you the various ways in which probability can be defined. These include the subjective approach as well as the objective approach, and then under the objective approach we have different ways of defining probability. But students, before I begin these formal definitions of probability, I would like to revise with you briefly the concept of mutually exclusive events, exhaustive events, and equally likely events. Let us begin with the concept of mutually exclusive events. As you now see on the screen, two events A and B of a single experiment are said to be mutually exclusive or disjoint if and only if they cannot both occur at the same time. In other words, they do not have any point or element in common. For example, when we toss a coin, we get either a head or a tail, but we cannot have both head and tail at the same time. Similarly, when a die is rolled, the events even number and odd number are mutually exclusive, as we can get either an even number or an odd number in one particular throw, and we cannot get both of them at the same time. Coming to real world situations, a student will either pass or fail in an exam. ये तो नहीं होगा ना कि वो बैक वक्त पास भी हुआ है और फेल भी हुआ है एक particular paper में. Similarly, a person will either be a teenager or he or she is not a teenager. It is not possible that both these things are happening at the same time. So I think you will agree that it is a fairly simple concept. And if we talk about three or more events at the same time, such events which are originating from the same experiment, they will be said to be mutually exclusive if they are mutually exclusive pairwise. On the contrary, if two events are such that both of them can occur at the same time, then of course we will say that they are not mutually exclusive. For example, if we draw a card from an ordinary deck of 52 playing cards, it can be both a king and a diamond at the same time. Therefore, kings and diamonds are not mutually exclusive events. जब हम playing cards की बात करते हैं तो आपको मालूम ही होगा कि एक ordinary deck of cards में 52 पत्ते होते हैं और 4 रंग होते हैं, हुक्म, चिड़िया, ईंट और पान. And in English, of course, we say spade, club, diamond and hearts. हर रंग के लिए 13 पत्ते होते हैं, 1 to 13, and for the three numbers 11, 12 and 13, we have pictures on the cards, and so we call them face cards, the king, queen and the jack. The cards of spades and clubs are black in color, and the cards of diamonds and hearts are red. And students, it is important that you keep all these points in mind, because a number of books that you will study in order to study problems of probability, you will find a number of examples relating to playing cards. All right, having discussed the concept of mutually exclusive events, I would like to revise with you the concept of exhaustive events. As you now see on the screen, events are said to be collectively exhaustive when the union of mutually exclusive events is equal to the entire sample space S. For example, in the coin tossing experiment, head and tail are collectively exhaustive events. Similarly, in the die tossing experiment, even number and odd number are collectively exhaustive events because if we take the union of the two, we get the entire sample space 1, 2, 3, 4, 5 and 6. Students, ये जो म्यूचुअली एक्सक्लूसिव इवेंट्स का कॉन्सेप्ट है, अगर आप गौर करें तो ये उस कॉन्सेप्ट के साथ बहुत रिलेटेड है जो मैं आपको लेक्चर नंबर 16 में दे चुकी हूँ, and that is the concept of the partition of a set. As you now see on the screen, a group of mutually exclusive and exhaustive events belonging to a sample space S will be called a partition of the sample space. And with reference to any sample space S, events A and A bar, the complement of A, will form a partition because they are mutually exclusive and exhaustive. This fact is clearly depicted by the Venn diagram because, as you can see, the events A and A bar are mutually exclusive. They do not have any points in common, and when we take the union of these two events, we obtain the entire sample space. All right, the next concept that I would like to review with you is the concept of equally likely events, a concept that is very, very basic and important for the classical definition of probability that I will be discussing in a short while. As you now see on the screen, two events A and B are said to be equally likely when one event is as likely to occur as the other. In other words, each event should occur in equal number in an indefinite number of trials. For example, when a fair coin is tossed, the head is as likely to appear as the tail, and the proportion of times each side is expected to appear in a very large number of trials is 1/2. Similarly, if a card is drawn out of a deck of well-shuffled cards, each card is equally likely to be drawn, and the proportion of times that we would expect any card to appear in a very, very large number of draws, this proportion will be 1/52. All right, having revised the concepts of mutually exclusive, exhaustive, and equally likely events, let us now begin the discussion of probability itself. As I said earlier, students, probability can be approached in two ways: the subjective approach and the objective approach. As you now see on the screen, subjective or personalistic probability, as it is called, is a measure of the strength of a person's belief regarding the occurrence of an event A. Students, probability defined in this manner is purely subjective. Subjective से मतलब ये कि different persons faced with the same evidence can arrive at different conclusions regarding the probability of a certain event. For example, suppose that a panel of 3 judges is hearing a trial. एक ही evidence है जो तीनों judges के सामने पेश किया जा रहा है. But it is possible that 2 of the judges arrive at the conclusion that the person who is accused is guilty, but one of the judges thinks that the evidence that is presented is not strong enough to arrive at this conclusion. So, students, you can see कि subjectivity का जो element जो मैंने आपसे पहले बात की, इसके अंदर बहुत ज़्यादा मौजूद है. एक ही evidence हो और एक ही situation हो, and different persons would arrive at different conclusions regarding the probability of a particular event. In fact, अगर हम गौर करें तो इस तरीके से अगर हम probabilistic decisions लें तो हम उन्हें quantify नहीं कर सकते. हम इस तरह के decisions अपनी रोज़मर्रा ज़िंदगी में हर वक्त ले रहे होते हैं. अगर आप घर से निकलते वक्त छतरी लेकर नहीं निकलते तो इसकी वजह यही होती है कि आपके जहन में ये बात होती है कि सूरज सर पे निकला हुआ है तो इस बात की probability बहुत कम है कि 5 मिनट के बाद बारिश हो जाए. इस तरह के डिसीजन हम लेते तो हर वक्त ही रहते हैं, लेकिन we are not able to quantify these probabilities the way we statisticians would like to do for our statistical work. This is why, for statistical purposes, the other definitions are the ones that we are more interested in, and these are the ones which fall under the category of the objective approach to probability. The objective approach implies that every person faced with a particular situation will arrive at the same result or the same conclusion regarding the probability of a particular event. Under the objective approach, the first definition that I would like to discuss with you is the classical definition of probability. As you now see on the screen, if a random experiment can produce n mutually exclusive and equally likely outcomes, and if m out of these outcomes are favorable to the occurrence of a certain event A, then the probability of the event A, denoted by P of A, is defined as the ratio m over n. Students, this definition was formulated by the French mathematician Laplace, and it can be very conveniently applied in those situations where the outcomes are equally likely and where it is easily possible to count the total number of outcomes and the outcomes favorable to a particular event. अगरचे इसकी definition बहुत ही लंबी चौड़ी मालूम हो रही है, लेकिन in reality it is very simple, and I would like to explain this concept to you with the help of an example. Suppose that a card is drawn from an ordinary deck of 52 playing cards, and suppose that we are interested in finding the probability that the card is a red card. Students, ये एक बहुत simple problem है और अब देखने की बात ये है कि हम इसको किस तरीके से approach करें. सबसे पहली बात ये है कि if it is a well shuffled deck of cards, बहुत अच्छी तरह से आपने उसको shuffle कर दिया है, तो intuitively आप understand कर सकते हैं कि जब आप एक कार्ड ड्रॉ करेंगे तो every card is equally likely to be drawn. हर कार्ड के ड्रॉ किए जाने का चांस बराबर होगा, एंड दिस पॉइंट इज द क्रक्स ऑफ द मैटर. अगर ये शर्त इक्वली लाइकली वाली इस सिचुएशन में पूरी हो रही है, तब तो हम ये क्लासिकल डेफिनेशन अप्लाई कर सकते हैं. अगर यही शर्त पूरी नहीं हो रही, तो देन देयर इज नो वे वी कैन अप्लाई द क्लासिकल डेफिनेशन. यहाँ पे अगर हम ये जानते हैं कि इट हैज बीन शफल्ड वेरी वेल, देन ऑफ कोर्स वी आर इन अ पोजिशन टू अप्लाई दिस डेफिनेशन. ऑलराइट, वंस वी आर सेटिस्फाइड कि हम इसे अप्लाई कर सकते हैं, उसके बाद दो ही काम बाकी रह जाते हैं. वी हैव टू कंप्यूट द रेशियो m over n. m is the number of outcomes that are favorable to what I want, but n, of course, is the total number of possible outcomes. And as you now see on the screen, in this particular example, the total number of possible ways in which we can draw one card out of 52 is obviously 52. Also, because we are interested in a red card, and because of the fact that we already know that the cards of diamonds and hearts are red in color, and there are 13 of each of them, therefore, the total number of outcomes favorable to what I want is 13 plus 13, and that is 26. Now that it is clear that m is 26 and n is 52, the probability that our card will be red is equal to 26 over 52, and that is half, or in other words 50%. कार्ड्स के इसी एग्जाम्पल में हम और बहुत सी probabilities compute कर सकते हैं. Suppose that we are interested in this event that the card that I draw is a 10, यानी उसका जो number है वो 10 है. Students, it is obvious that the total number of tens in this deck of cards is 4. A 10 of diamonds, a 10 of hearts, a 10 of spades and a 10 of clubs. लिहाजा वो पत्ते जो 10 की अक्रेंस को फेवर करते हैं, उनकी तादाद 4 है. m is 4. n, the total number of ways in which I can draw a card out of this deck, is as before 52, and therefore the probability that my card is going to be a 10 is equal to m over n, 4 by 52. Let us consider another example. Suppose that we toss a fair coin 3 times. As you now see on the screen, the sample space of this experiment consists of 8 possible outcomes: head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head, and tail, tail, tail. Suppose that we are interested in finding the probability of the event that when we throw these 3 coins, or this one particular coin 3 times, we get at least 1 head. Students, अब हम उसी तरह अप्रोच करेंगे इस प्रॉब्लम को जिस तरह हमने अब से थोड़ी देर पहले इससे पिछले एग्जाम्पल में किया था. The very first thing to try to understand is कि वो जो शर्त है equally likely की, is that valid for this example? Now the point is that we said that it is a fair coin that we are tossing 3 times. If it is a fair coin, अगर वो इस तरह से बना हुआ है कि बिल्कुल सही है, टेढ़ा नहीं है, एक साइड से घिसा हुआ नहीं है, then it is obvious that we can say that the tail is as likely to occur as the head. और हाँ हम उसको एक दफ़ा टॉस करें या 3 दफ़ा टॉस करें, उसकी ये प्रॉपर्टी फेयरनेस की जो प्रॉपर्टी है, that will be maintained. इस rationale ke through, we are quite satisfied that the outcomes, the various outcomes, the two possible outcomes actually, head and tail, they are equally likely to occur. Once we are satisfied that this is the case, we can very quickly apply the classical definition of probability, m over n, where m is the number of outcomes that are favorable to what I want, and n is the total number of possible outcomes. In this example, as you noticed, 7 of the 8 possible triplets contains an H, and only one triplet, tail, 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 is the one which is without the head. Hence, the probability that my outcome, my triplet, will contain at least one head is given by m over n, that is 7 over 8. अभी जो एग्जाम्पल हमने डिस्कस किए ये तो बहुत ही ज़्यादा सिंपल एग्जाम्पल थे, लेकिन आपने नोट किया होगा कि मैंने इस बात के ऊपर बहुत ज़्यादा जोर दिया कि आप सेटिस्फाई हों कि इक्वली लाइकली की जो डेफिनेशन है वो अप्लाई होती है या नहीं होती. इट इज़ वेरी इजी टू learn the formulas and to apply them, but it is more important to realize that unless the assumptions of that particular formula are not valid, we must not apply those formulas. Let us now consider a more interesting and a little involved problem, as you now see on the screen. Suppose that 4 items are taken at random from a box containing 12 items, and the 4 that are drawn, they are inspected for checking whether they are faulty or whether they are all right. The box is to be rejected for export purposes if more than one item is found to be faulty. Now, if there are 3 faulty items in that box, what is the probability that the box will be accepted? आपने नोट किया होगा कि ये काफ़ी इंटरेस्टिंग प्रॉब्लम है. अब इसमें स्टूडेंट्स सबसे पहली चीज़ ये है कि हमने ये कहा कि वो जो इंस्पेक्टर है, he is drawing these items from this box at random. ये जो 2 अल्फाज मैंने इस्तेमाल किए, these are very very important. Random का मफहूम यहाँ पर यही है ना कि it is as if it is the lottery method. कोई उसमें intentional selection नहीं है और randomly आप draw कर रहे हैं. Now, because of this randomness, we can say that each one of those 12 items is equally likely to be drawn. And the moment I say this, I am in a position to apply the classical definition, and that is m over n. But students, in this particular problem, it is not as convenient to compute m or n as it was in the earlier ones that I presented. देखिए, यहाँ पर we will be applying the rule of combinations. आप नोट कीजिए कि डिनोमिनेटर जो है हमारे फॉर्मूले का n, that represents the total number of possible outcomes, or in other words, the total number of ways in which I can draw 4 items out of 12. But of course, there is no importance of the order in which I draw these items. Order की अहमियत नहीं है, लिहाजा it is not a case of permutations, but it is a case of combinations. And according to what I explained in the last lecture, there are 12C4 ways of selecting 4 items out of 12. And as you now see on the screen, 12C4 is equal to 12 factorial over 4 factorial into 12 minus 4 factorial. And when you solve this expression, it comes out to be equal to 495. The computation of the numerator m is a little more involved, and actually it is very interesting. इसमें हम rule of combinations, rule of multiplication और rule of addition तीनों बैक वक्त इस्तेमाल करेंगे. Let me explain it to you step by step. देखिए, हमारे बॉक्स में 12 items हैं, out of which 3 are faulty and 9 are all right. Now, I want to find the probability that my box is accepted and it is not stopped from being exported. और उसके लिए हमने पहले कहा था कि a box is rejected if 2 or more items out of those 4 that have been selected, if 2 or more are found to be faulty. इसका मतलब ये हुआ कि अगर मेरे 4 selected items में से एक faulty है तो it is no problem, और अगर एक भी faulty नहीं है then of course there is no problem at all. इसका मतलब ये हुआ कि जो favorable outcomes हैं, जो इस बात को favor करते हैं कि मेरा जो box है that will not be stopped from being exported, वो 2 ही हैं. One is that situation when out of the 4 selected, not even one is faulty, and the other is that situation when out of the 4 selected, only one is faulty. So, we will be computing the number of ways in which the first event can occur and the number of ways in which the second event that is favorable to what I want can occur. And then I will add the two, and that will give me the total number of outcomes favorable to what I want. As you now see on the screen, in order to compute the number of ways in which all 4 of my drawn items will be all right, we note that there are 3C0 ways of drawing 0 faulty items out of 3 faulty items, and there are 9C4 ways of drawing 4 okay items out of the 9 which are all right. And hence, the total number of ways in which the joint event no faulty item and 4 all right items can occur is given by 3C0 into 9C4 in accordance with the multiplication theorem that I discussed in the last lecture. बिल्कुल इसी तरह we can find the number of ways in which we can have 1 faulty and 3 all right items. And as you now see on the screen, the total number of ways in which this can be done is 3C1 into 9C3. 3C1 ways of drawing 1 faulty item out of 3 and 9C3 ways of drawing 3 all right items out of 9. Students, अगला point ये है कि जैसा मैंने पहले कहा, the box is going to be accepted if we have no faulty item or 1 faulty item. ये जो लफ्ज़ or मैंने इस्तेमाल किया, जैसा कि आपने सेट थ्योरी में नोट किया था, or stands for plus, यानी or का मतलब है सेट थ्योरी की रूह से कि आप यूनियन की बात कर रहे हैं. और जो डिस्कशन हम इस वक्त कर रहे हैं, इस कॉन्टेक्स्ट में or stands for plus. So, as you now see on the screen, the total number of outcomes that are favorable to the fact that the box is accepted is given by 3C0 into 9C4 plus 3C1 into 9C3, and that is equal to 126 plus 252, in other words 378. Dividing the favorable number of outcomes by the total number of outcomes, the probability that the box is accepted in spite of the fact that it actually contains 3 faulty items is 0.76 or 76%. Students, as you have noticed, the classical definition is quite a simple definition. लेकिन देखने की चीज़ और नोट करने की बात यह है कि this definition has a number of shortcomings. सबसे पहली बात आप ये देखिए, and this is a very interesting point, that this definition involves circular reasoning. जैसे कि मैंने define किया था, हमने कहा कि if a random experiment can result in n equally likely and mutually exclusive and exhaustive outcomes, and m of them are favorable to the occurrence of an event A, and so on. Students, इसके अंदर ये जो दो अल्फाज मैंने इस्तेमाल किए, that those outcomes are equally likely, इसका मतलब ये है कि मैं ये कह रही हूँ that the outcomes are equally probable. अब देखिए कि probability ही को तो मैं define करने की कोशिश कर रही हूँ, और उस definition के अंदर ही I am using the word or using the concept of probability. This is called circular reasoning. और इससे मुझे एक लतीफ़ा याद आ गया. एक बच्चे ने एक साहब से पूछा कि स्कूल किधर है, और उन्होंने कहा कि मस्जिद के सामने. तो बच्चे ने पूछा कि मस्जिद किधर है, तो उन्होंने कहा कि स्कूल के सामने. And this is the kind of problem that we have in this particular definition. Having said this, I would like to convey to you students कि ये जो equally likely का concept है, ये intuitively understandable है. और जैसा मैंने सारी discussion जो अब तक की उसमें explain किया, अगर आपको उस phenomenon की जो physical situation है, उससे ये महसूस होता है कि equally likely का concept यहाँ पर apply करता है, then you can apply this definition. Now, the other problem with this particular definition is that it is very difficult to apply, and it's probably not possible to apply it if the total number of outcomes cannot be counted in a convenient manner, as we have done in the examples that we just did. अगर आपकी sample space जो है, उसमें infinite number of sample points हों या uncountable number of sample points हों, then it is not going to be possible for you to apply this definition. The third problem with this definition is that it does not hold if the outcomes are not equally likely. And in my opinion, this is one of the main problems with this definition. हजार real life phenomena ऐसे हैं कि जहाँ पे we cannot say that one event is as likely to occur as another. अब ये जो example है कि आप coin toss कर रहे हैं या die toss कर रहे हैं, आप खुद ही सोचिए, हम आम life में इस किस्म के experiment कितनी मर्तबा करते हैं? Practically never, except perhaps when we are playing a game as a child, a game of Ludo or any other such situation. So, generally speaking, we will not be dealing with situations where the various possible outcomes are equally likely. And students, these are exactly the situations when we will need to look for another definition of probability. The definition that I am going to present to you next is called the relative frequency definition of probability. Students, इस definition को मैं in detail next lecture में आपके साथ discuss करूंगी. इस वक्त मैं बहुत मुख्तसर करके आपको ये कन्वे करना चाहती हूँ कि according to this definition, if an experiment is conducted a very large number of times and what we are interested in occurs a certain number of times, then the proportion in which the event of my interest occurs, that proportion is regarded as the probability of that event. इसको एक मिसाल से समझने की कोशिश कीजिए. आप देखते हैं कि हर साल मैट्रिक के एग्ज़ाम में बहुत से स्टूडेंट्स बैठते हैं, बहुत से रेगुलर स्टूडेंट्स होते हैं और शायद उनसे ज़्यादा ही प्राइवेट स्टूडेंट्स होते हों. And when the result arrives, of course, we find that a certain proportion of the students obtain the first division, another proportion obtains the second division, and a certain proportion also fails in the exam. Students, ये जो proportions हैं, इन्हीं को हम regard करेंगे as the probability of obtaining a first division, the probability of obtaining a second division, and so on. ये बिल्कुल उसी rationale के मुताबिक जो मैंने अभी आपको convey किया. So, if we find that in the metric examination of 2002, in a particular province of a particular country, the proportion of first divisioners is 25%, then we can say that the probability that a student of this particular country, in this particular kind of a situation, the probability that he will obtain a first division is 25%. In today's lecture, I discussed with you the two main approaches to probability, the subjective approach and the objective approach. Under the objective approach, I discussed in detail the classical definition of probability. And I would like to encourage you, students, to practice with this concept and to attempt a number of questions involving the classical definition and involving the various counting rules, such as the rule of combinations and permutations. In the next lecture, I will discuss in detail the relative frequency definition that I briefly touched upon today, and after that, we will proceed to the axiomatic definition of probability. Until next time, my best wishes to you, and Allah Hafiz.